Okay, well, thank you to all the panelists. As a reminder, you can attendees can ask questions by using the Q&A box at the bottom. We do have a couple questions, and I believe our panelists are on. So there we go. There we go. We're trying to follow the instructions from our TIDC folks behind the scenes. So thank you. So Tony Donovan asks, question for you, Jeff. Could you speak to the temporal separation as a way to operate interurban light rail transit on the state-owned railroad that are not currently operating freight and may only need to cross the freight main line at Yarmouth and Danville junctions? For example, freight use of the state railroad could be at night.
Sure. Well, temporal separation, running passenger trains during the day and freight at night is a great way to minimize the likelihood of a collision. Passenger equipment is not exactly the same thing as freight equipment. They're not necessarily crash-worthy compatible. So separating that is a great way to do it, especially with, I don't know what the equipment is you're referring to, but transit equipment is not as strong as a freight car necessarily, or a locomotive. So my experience with this, we did this back in 2011, I think, with Denton County Transit in regard to its acquisition of Stadler passenger rail cars that were the first ones to be, I'll say, qualified to FRA's structural requirements, using an alternative method that was developed to allow European rail equipment to be brought to the United States. It was like an equivalency of, and Stadler and DCTA were the first ones to go through it. And while that was being done, the equipment was available, so they went into service under a temporal separation arrangement with the railroad, the operator, the freight operator, and that was very successful. FRA was pleased with that. It doesn't come easily necessarily. I mean, I don't know these particular lines that you're referring to about how dense the freight traffic is and how frequent the freight trains are, but if mutual agreement can be had between the passenger operator and the freight operator, it's the way to go. It definitely improves safety. I don't know if that answers your question. You can type more if I didn't hit it.
Thank you, Jeff. Yeah, please do add, folks, if you want to add to your question for sure. Moshul asks, Riley, thank you for sharing your research project. I'm curious to know if you conducted a data analysis to monitor the level of vegetation on the track as well as using the collected data. Could you also provide more details on the structure of your training data? Moshul says he's confident laser scanning technology with AI can monitor other features like vegetation on track. Curious about the amount of effort required to update the training data.
Great question from Dr. Shen, and thanks everyone for listening. This has been an exciting event thus far. To answer, maybe more broadly answer about the question about the training of the data using AI. So we use deep convolutional neural networks, common approach for image recognition, classification, and recognition of attributes within those images. So we would set aside training images, and then we would check the effectiveness of the algorithms at recognizing certain components and whether they're effective or not. So we would store back images for testing. The actual percentages, typically it's 80-20 as the ratio in favor of holding back some images to test the algorithms. Primarily what our team here at Illinois did is we provided rail domain knowledge to classify the images. So we spent a lot of time at the HTL, high tonnage loop out at TTC in Pueblo. We either induced our own defects in the track to create images that we could help train the algorithms for use in the future, or we used the existing track that was there. So we would get both good and bad images to train the deep neural networks. The question is an exciting one, actually one that we related to vegetation. We talked about this yesterday internally within our team meeting. Retraining the neural networks is really simple. It's relatively straightforward. Railmetrics manages a lot of this work internally, but we here provide kind of domain knowledge to say, hey, instead of recognizing this particular type of fastener, can we also look at another type of rail fastener? And we can provide some images that are representative of that, and they train the algorithms relatively quickly because we have a large data set at this point. Vegetation specifically, the images that Dr. Shen's talking about, we highlight areas where we see surface fouling of the ballast, and that's just done by looking at the change in the coarseness of the aggregate. So when we see fine aggregate or fouling on the surface, that's what the neural network is highlighting in those images that show surface fouling. So retraining the algorithms, relatively straightforward, and they've far exceeded my expectations in turnaround time for re-upping the algorithms for new track components.
Great. Thank you, Ryan. Sebastian Montoya has a good question. I think, Joe, this is probably in your line. Passenger transportation, do you think there's a need for a train culture education to shift people preference from car, bus, plane to train?
I mean, it's I guess both a philosophical question, but also sort of a more practical question. I think that I mean, I think in general, as we think about climate change and, you know, how we need to travel in the future, and the fact that, you know, certainly gas powered private or, you know, internal combustion engine powered private automobiles and, you know, carbon neutrality needs to be, you know, the cars need to be less emphasized and the carbon neutrality needs to be more emphasized. I think, yeah, there's kind of a general, I mean, I don't want to call it sort of education, but more just, you know, sort of awareness that people have to have and looking for different ways to travel. I think, you know, but it's also incumbent on, you know, Amtrak and others to, you know, make our service attractive and competitive and, you know, market why it's, you know, can be a better option. So for just as an example, you know, one of the things that we're pretty focused on right now is that although, you know, the train may not be the fastest way to get somewhere, you can be productive in whatever way that means, whether that's doing some work or taking a nap. That may be the most productive use of your time at that moment. Things that you can't do, hopefully, while you're driving. So I think, you know, trying to just show people how this can be, you know, part of their transportation, you know, solution, you know, in a way that it might not have been in the past.
Thank you, Joe. Yeah, just a reminder for attendees, if you have questions, you can go ahead and use the Q&A button. I see Jim has a question. Jeff, what are the likely next steps before implementation of these collision energy absorption devices? Roughly how long might this take for implementation? Good question, Jim.
Yeah, thank you for that. It wouldn't take long at all. The purpose of that whole test program, which involved other things that we did prior to what you saw today, was geared at coming up with a scheme that would allow crash energy management functionality to be applied to locomotives that are older, which may not have this capability. But acknowledging the fact that rail equipment stays in service for many, many years. So locomotives can last, I don't know, 30 or 40 years if they're well maintained. So those older locomotives could be retrofit with the structures that I described this morning in order to improve their crashworthiness. Our hope was that this would be something that we could demonstrate, provide the drawings, provide all of the information that we developed, all the technical background, so that operators could upgrade their locomotives using these components. The coupler is essentially off the shelf, and the arrangement of the crush tubes and the sizing of them are standard fare for a metal fabricator to create. So there is no real timeline. It's basically, we did a demonstration. We're trying to get the word out. We like to show it to people like you and others so that they can see it and say, well, gee, that's not a half bad idea. We can improve the safety of our engineers and crews by doing something like this.
Thank you, Jeff.
Sure.
I do have a question, Joe, for you. And I applaud the work that you folks are doing on resiliency and climate and in trying to plan and look ahead. On the highway side, when the road floods, typically there's not a lot of science behind when we reopen it, right? So a roadway could get totally overtopped with water and it will recede, and then not a lot of science behind, is the road safe now, so I'm curious as to if Amtrak or the rail industry in general is looking at methods to ensure that the rail is safe after floodwaters recede, if there's any methodologies or engineering or science behind that.
I mean, it's an excellent question. I'm unfortunately probably not really qualified to answer it per se, but I guess the two things I would say are, I think that as, well, one of the things I learned early on in my career thinking about, railroad infrastructure is, the three most important things about track design are drainage. And, the impact of water on the tracks and not knowing not necessarily being able to evaluate what impact it's had, is I think a big concern, because you may look visually like it's fine, but if it's not draining well, then there may be something happening below the surface. So the drainage, just in general, leaving aside flooding or climate impacts, drainage is critical. But I do think it's an area of potentially interesting research, because as climate events become more significant and we have sort of more violent storms potentially, and rainstorms at unexpected times, like in the middle of the winter, rather than snow, being able to quickly understand is not just the visual element but the actual track structure safe, and something hasn't happened below the surface, because generally the rule of thumb I've always heard is if you can see the top of rail, then it's probably okay. But again, with more violent storm events, that may not be a great standard going forward.
Yeah, thank you. Riley, question for you on the ballast surface fouling. So does that indicate deeper intrusion? Is there opportunity for further automated sensor research to detect deeper ballast intrusion?
Yeah, that's a great question. One of the slides that I did not have in this presentation, and I know there's a broad kind of array of individuals that are a part of this conference. So just as a high level understanding, there's a bunch of different track inspection technologies we can take advantage of, from traditional track geometry inspection measurement systems. We have GPR systems that can see down into the substructure and determine at least layers, thicknesses, and give us a little bit of insight into ballast fouling. So we have a lot of different technologies we can use to inspect the track structure. This system that I showed you is purely visual and laser based. So we're looking, if it's not something you can kind of see or measure with your eye, you don't have a way of obtaining that insight. So it doesn't do what GPR does to the individual's question. GPR can look into the subsurface attributes of the track system. We cannot do that. And back to Dr. Shen's question, many people in this meeting are probably familiar with LiDAR. And LiDAR typically can be used in applications where you need a much wider view of what's going on with the right-of-way. So for vegetation control, for instance, Amtrak makes extensive use in the Northeast Corridor. A lot of other locations use LiDAR to get kind of the broader view of the track cross-section, the right-of-way, the ditches, the vegetation. This is the micro view. What I showed you today is the micro view, microscopic view of looking at the health of the track components. So it may not be the best tool to look at vegetation, and it sure isn't the best tool to figure out your sub-ballast thickness. But surface fouling, we're coming to find out is a helpful metric when we look at it in light of other data streams, whether that's geometry or the health of the cross ties or the health of the fastening system that we get from this technology. So it does not solve your substructure inspection. If you care about that, you need GPR, ground penetrating radar.
Thank you, Riley. We have a few more questions. For Jeff, has there been or is FRA considering research on vehicle bridge impact?
Train to bridge impact? Not to my knowledge. We've done a lot of testing to establish, to help characterize the strength of car bodies, passenger cars, locomotives, using a crash wall that we have at the Transportation Technology in Pueblo, Colorado. It's just this giant mound of dirt with a very thick concrete layer on the front, a perfectly flat wall. We use that to evaluate the strength of the vehicle. I think what your question is about here is what kind of damage can a train do to a bridge or bridge abutments or bridge structures? And the answer is, I don't believe that that's being contemplated at this time. I hope that answers your question.
Okay, we have a question for all three panelists. Given the nature of the TIDC and you know the focus of the research focus of the center, do you see any obvious opportunities? I know you've touched on a couple. I know Joe mentioned something and others, but any future rail research that we should be thinking about TIDC? We'll start with Joe. Sorry, Joe, put you on the spot.
That's okay. Put me on the spot. Geez, I mean, there's probably lots of different pieces. I mean, I think that, you know, in general, you know, again, like I said, you know, figuring out how to make sure that, you know, as climate events become potentially more violent and more frequent, how do we, you know, have systems in place to, you know, better protect our infrastructure, you know, particularly as we move more, I would assume in the future into electrification. That depends on, you know, overhead power structures, which are themselves susceptible to climate events. And so, you know, are there either, you know, better technologies out there for, you know, how you mount and maintain and you know, ensure some reliability for type of overhead structures for, you know, the catenary, or, you know, make them easier to restore once the you know, if there is damage or if there is a, you know, wind event or something like that. So I think that's one that just jumps out at me, because I do see, you know, not nationwide, but in busy areas, I would see more electrification, you know, as part of the solution to, you know, you know, reducing the dependence on diesel fuel for trains.
Riley?
A great question. I think one opportunity for researchers is to start with what we have in the US, that we're fortunate to have a great database from the FRA regarding train accidents. So one opportunity that we have as researchers is to peruse that database, to look at what the data tell us in terms of the accident cause codes that are the most important ones for us to be reducing. And we need to look at the recent years data too, not just what we were thinking about 20 years ago, but as we see trends in accident causes shifting, we need to be able to address those. So there's analogs on Jeff's side of things, Jeff Gordon's side of things at FRA on the mechanical side, but on the track side for me, we look at frequency versus severity. So what are the accidents that are occurring with above average frequency and above average severity? What are these cause codes, and what can we be doing to investigate new materials, designs, methods, inspection procedures to address these items? So the people on the call, the academics and the other researchers that have that domain knowledge about material science or sensing technologies or structural engineering, think about how you can apply that to the accident cause codes that occur with above average frequency and severity. Tackle those first to drive down the accident rate.
Great, thank you, Riley. Jeff?
Well said, Riley. That's perfect. Well, my approach was, I'm an equipment guy, not necessarily an infrastructure guy, but one of the takeaways I was hoping that people who watched this might have is that, you know, given the focus on inclusivity and all of that, and the need to accommodate, you know, passengers with disabilities, most notably ones in wheeled mobility devices, which vary. There are many different types and sizes and shapes of these. Amtrak and other passenger operators account for wheelchair riders and provide spaces where these wheelchairs can be either stored or that the occupant can sit in a train. But as I showed you, lots of things can happen, and collisions and derailments, and those occupants need to be afforded the same kinds of protection that other passengers get. So I was hoping people who saw this might think about different ways that you could constrain or restrain the wheelchair or the occupant or both in ways that were convenient, that allow the occupant to have independence, to be able to move around the train when he or she wants to, but yet again, be able to return to a place that's safe in the event of a collision. So that was what I was kind of hoping for. And these are the kinds of things that engineers or whoever might be on the call can think about, you know, whenever they're just thinking. We're looking for innovative ways that allow passengers to maintain their independence and provide safety.
I guess, Dale, just building on what Dr. Edwards said, I think, you know, we have, you know, constant issues with, you know, grade crossing crashes and trespasser strikes. And, you know, so I think particularly on the sort of grade crossing side, you know, there's a lot of technology there already, but, you know, as sort of cars become smarter, you know, is there a way to add additional tools to warn people when the train's approaching? You know, like, for example, like Waze has recently started telling me when I'm approaching a railroad crossing, but, you know, is there some future evolution of that where it actually knows, well, there's a train coming and tells me, you know, not necessarily very super precisely, but, you know, there's a train somewhere in the area, you know, tries to warn me to be more vigilant or something like that. Not that you shouldn't be vigilant anyway. So I think, you know, thinking about are there ways to use new technologies to, you know, it is sort of an infrastructure reliability question of, you know, not having these types of crashes, because as soon as you have, you know, a trespasser strike or a grade crossing incident, that railroad line is shut down for, you know, anywhere between a few hours and, you know, many days, depending on how severe it is.
Great, thank you. So we just have a couple more minutes. I don't see any questions in the Q&A. So I was hoping maybe panelists, if you had anything else that you'd like to add to what we've talked about. Riley, anything?
No, I appreciate the opportunity to get to speak with these other gentlemen. I think it's fun when we have the opportunity to cross-pollinate with some of the other disciplines. I mean, Jeff and I have been in the industry for many years and have never spoken in the same event. So thanks for the foresight in connecting some of these topics.
Great, thank you.
Agreed.
Jeff, anything?
No, I agree. I was going to say the same thing, and I'm just happy to be here, and thank you for having me, and I hope that the audience enjoyed it. Thanks again.
All right. And Joe, anything else to add?
I guess I'll repeat my thank you for inviting me to participate and having the opportunity to be on a panel with such distinguished industry experts. But I guess the one thing I'd say is just, you know, sort of hearing the other presentations, particularly Jeff's, you know, as he alluded to during the Q&A, you know, these are assets, whether it's the physical, whether it's the infrastructure or the vehicles or the, you know, locomotives and the rolling stock that, you know, are long lived and, you know, take a long time to build and upgrade. And so I think, you know, pushing from a research perspective, you know, anything we could do to sort of push the state of the art forward quickly is important, because, you know, Amtrak in particular, we're in the midst of, you know, basically this unprecedented equipment replacement. We're, you know, buying new intercity aero train sets. We're, you know, you may have seen, we're, you know, just launching the process of replacing all of our long distance fleet. We're buying new locomotives. So, you know, there's a sort of moment in time where if some of these, you know, research initiatives can really have an impact, in the near future, I think it can really, they can have a significant impact because there's so much going on right now. So I appreciate all the work that the sort of, academic side of things are doing to, try to push the industry forward from a, innovation perspective.
Great. So we will wrap up. A great thank you to you gentlemen for joining us and for the presentations, and I think for the good dialogue and Q&A afterwards. We do greatly appreciate this. So thank you all. Folks, we're going to take 15 minutes now for a break. We'll be back at 11:30 sharp with session 2. And that's the TIDC Research in Action. Thank you very much.
Thanks, Dale.